Good morning, students. I am Salim from Department of Electrical and Electronics Engineering. Today I just show you the introduction of IoT and embedded system. Over here, this is the code for IoT and embedded systems. This curriculum is designed to provide a comprehensive education in IoT field and embedded field. So this course basically focus on 4 core areas. First one, sensing device, transducers, then embedded system fundamentals like microcontroller, microprocessor, just introduction, and then how to program these boards. In this we also focus on IoT board, that is Node MCU. We include ESP8266. After that we just use smart sensor technologies. Some case studies are there. Over here we have practical exposure like to the field of IoT and embedded system. We have set of 15 experiments to cover these fields. So a dedicated lab course where students gets hands-on experience on Arduino board, on ESP board, on Raspberry Pi with different sensors. They interface these sensors with these controllers or microprocessor and get the data on your computer, on your mobile phone, etc. So these are some presentation outlines. Credits distribution, it is in first semester right now. After that, first half students learn in first semester, remaining half students of first year learn in second semester. So second is need, application area of the subject, course objective, course outcomes, mapping with COPOs, detailed syllabus, reference books, the continuous assessment strategy. It is most important for KITE students. So over here we have the subject IoT and embedded system and the lab. Total credit for these two is 3, 2 for the subject, 1 for the lab. 2 hours dedicated to the 2 lectures dedicated to the subject and 2 lectures dedicated to the lab where hands-on practices are there. So over here we have the need and application of area of this IoT and embedded system, as you see in the smart cities, smart home, healthcare system, transportation, smart manufacturing, smart cars, agriculture field, home appliances, wearable devices for health checking, energy management system. In every field you just find out the applications of IoT and embedded system. The course objective aims to provide exposure to the application of IoT in smart cities and industrial applications. It aims to train the students to the basic concept of embedded C. Aims to train the students the basic concept of controller, how to work with different controllers, like how many digital pins are there, how many analog pins are there, how to program it to run accordingly. Okay, this course is designed to give the students hands-on experience with software and hardware concepts. The main aim of this subject is to remove the fear of hardware interfacing from coding branches and software programming fear from the non-coding branches. Okay, so over here some course outcomes are there. Student will learn or understand the basic concept of sensors and transducers, understand the basic concept of embedded system and different IoT boards, apply basic operations and programming techniques of different IoT devices, apply smart technology knowledge through case studies. Okay, so over here we have the mapping, course outcome with program outcome. So this is the detailed syllabus. In the first unit we discuss about sensors and transducers, different types of sensors, it is not limited to this syllabus. Then in the second unit we have embedded C, Arduino programming, Raspberry Pi programming, interfacing with Arduino. Mainly in the subject area we focus on simulation part, that is done through Tinkercad software. There are different simulation software available in the market. We just use Tinkercad. In the third unit we have IoT board like ESP8266. We just interface different sensors through this board and we just publish the data on the Blink IoT app. Okay, in the last unit we have smart technologies. Some case studies are there like air monitoring devices, soil health monitoring, water quality monitoring devices are there. So these are the list of experiment. For every IoT and embedded system, the students should learn about 6 things: how to acquire digital signal, how to acquire analog signal, how to generate digital signal, how to generate analog signal. Beyond this, 2 more things are there: how to acquire PWM signal, how to generate PWM signal. Basically, as you see in the first 6 experiment, we just go through these fundamentals. First experiment is about the introduction of Arduino and ESP8266 board. What is the pin diagram, what is the how many number of pins are there, digital pins are there, how to configure this. And then in the second part we just use commonly used IoT sensors like DHT11 temperature and humidity sensor, HCSR04 ultrasonic sensor, IR sensor, PIR sensor, flame sensor, sound sensor. We just introduce or MQ series sensors to detect the gas. So we just discuss about these sensors. Then third, fourth, fifth, sixth experiment about digital signal and analog signal acquiring and generation. After this we just log the data through Arduino and ESP on your system. Let's say one sensor is there, humidity and temperature sensor. We just log the data in our system or save the data in a memory. Then we have light control system using LDR. Then we have multiple sensors interfacing through Arduino or ESP32 or ESP8266. Then we have object detection using ultrasonic sensor with Arduino and ESP. You can use ultrasonic sensor for height measurement also or level measurement also. Okay, then we beyond the syllabus we just have ThinkSpeak. We just publish the data, real-time data over the ThinkSpeak platform through Arduino or through Node MCU. Then we have Blink IoT app. We just aware about or we hands-on work on Blink IoT app. We just interface DHT11 sensor. Then we also control different household appliances like how to control a LED bulb, how to control a fan, how to control any appliance through IoT or Blink IoT using ESP8266. Then we have beyond building a soil health monitoring system, that is NPK sensor. In this sense, using this sensor we just measure the soil health, like how much nitrogen is there, how much potassium is there and phosphorus is there. Then we just measure the quality of water also. These are some reference books and text books. These are some legends behind the subject IoT and embedded system. The father of IoT, Kevin Aston, he is a British technology pioneer. He created IoT in 1999. Okay, nearly in early 20th century. Okay, then we have inventor of LED. Then we have father of internet. Okay, so these are some legends. So over here some MOOC courses or video lectures available on over Internet of Things and embedded system. You just go through it. This is the example of Tinkercad using ultrasonic sensor. As you see, HCSR 04, we just interface it to the Arduino. It is simulated over Tinkercad software. This is most important part of the PPT. The IoT and embedded system divided into two parts. One is the subject course, that is 2 credit. One is lab course, credit is 1. So the exam for this, it is for the kite students. Exam for this is based on without paper and pen. It is based on basically project based learning. You have to create a project and you have to explain it in your mid semester examination and in the end semester examination. So over here is the assessment strategy. So over here, as you see, this is the mid semester examination. It is carrying 40 marks, end semester examination carrying 50 marks, and over here we have quiz of 10 marks, 5 marks for the quiz, 5 marks for the attendance. The mid semester examination divided into two parts during the CTs or your mid semester examination. Like in first part we have level 1, in the second part we have level 2. Both are divided into 20 marks. These are evaluated by your teaching faculty, okay, and the external is evaluated by external faculty, okay. So over here we have some category in the students like graduate students, growing students and gallant students, and these are two levels in which some basic projects are there. Like level 1, it is basic level, level 2 is the advanced level. We just divide all these projects in 3 categories based on these graduate students, growing students and gallant students. So if you select this project in a group of 4, you just select a basic project or advanced project for mid semester examination 1 and mid semester examination 2 that carry 20 marks. So if you select over here, the weightage is 80%. If you select from here, this is the complexity level 1A, this is the complexity level 2A. If you select from these two categories, your marks out of 8, not out of 10, if the weightage is 10, okay. If you select from these two categories, the marks is out of from 9 each, not from 20, okay. If you select your project from these categories, then marks will be out of 20, okay. Full weightage is there. This is the complexity level C, A, B, C, these are the complexity levels, okay. So it is for the continuous assessment for level 1. It is evaluated by your teaching faculty. These are some categories like presentation over your project, whichever project you selected in your classroom or in your lab. Basically it is for only classroom, not for the lab. So presentation carrying 10 marks, hardware knowledge 4 marks, software knowledge 3 marks, project status working or not carrying 3 marks, and the presentation further divided into 3 parts: knowledge of the project, communication skills and teamwork, okay. In this part, in the level 1, basically it is basic level, so you need not to submit any report over it, okay. So over here, this is the level 2. There is one simple difference, that is you need to submit a report that carry 5 marks, that is case study related to your project, okay. So as you see over here, again it is evaluated by your teaching faculty: presentation, hardware, software and project status. Then presentation is divided into again 3 parts: teamwork, communication skills and case study and report. So this is the final assessment evaluated by external faculty. Internal faculty also present over there. So again it is divided into 4 parts: presentation, hardware knowledge, software knowledge and project status. So it carries 50 marks, okay. So presentation carries 20 marks, 5 marks for teamwork or knowledge, 5 marks for quiz and 10 marks for report. You just need not to create another report, you just update your previous level 2 report for evaluation of this final evaluation and semester examination marks, okay. So this is the for lab evaluation strategy for the lab. As you see, continuous lab evaluation, attendance marks are 5, continuous assessment, that is based on project based learning, 20 marks. Every project is in the lab is based on hardware, mainly hands on experience to different experiments. So over here these are 4 categories: course outcome 1, course outcome 2, course outcome 3, course outcome 4. So these are divided into 3 parts mainly. Viva is there, 1 marks. It is not based on group wise, it based on individual. Okay, Viva, quiz, report work. Okay, so now over here as you see, mapping of the course outcome with lab experiments. So we just mapped 10 experiments over here with course outcomes. These are some companies that deal with IoT and embedded system: ST Microelectronics, Texas Instruments, Intel India, L&T Technology Services, VVDN Technologies, NXP Technologies, Honeywell, Siemens Technology, Mint, Mindtree Limited, Tech Mahindra. These are some companies, famous companies. So this is all about uh, today's lecture. This lecture is basically for the kite students only. It is not for other students. Okay, thank you.